Hello, this is Mr. Ware, and today we're looking at mapping and trying to determine if a relation is a function or not. So let's begin. So, uh, we are continuing the lesson on determining if something is a function or not. We started with the vertical line test, and then we went to ordered pairs, and now we're doing mapping. So before we get into determining whether it is a function or not, I want to start off with knowing what mapping is. So let me explain. So mapping gives you an input and an output. And all mapping is a different representation of the same thing. So just like the graph can be done with ordered pairs could be turned into mapping. So this is just a different way to represent it. Okay, so you have your input, which is your x values. And you have your output, which is your y values. Okay, and what mapping does is it puts all the x values in numerical order and all the y values in numerical order and doesn't repeat. And all you got to do is draw a line to what it connects to. So for example, 4 goes to 5. And if you look at, if we put this as a ordered pair, it'll be 4, 5. Alright, 6 goes to 5, 8 goes to 0, 9 goes to 2, and you have those ordered pairs just like that. So it's just a different way of representing it. Now, to determine whether it's a function or not, what you want to do is the quickest, easiest way to do is look at all your x values and see if there's two lines coming from it. If there's two lines coming from it, then it is not a function. That simple. Okay? But I want to explain to you why. So, as we got these points down here, as we determined in the previous lesson, that the 4 or the x values here has to be its own number. It shouldn't be two x values. Okay? So as soon as you see two x values, you know from the ordered pair that it's not a function. Two of the same x values. But here, they're only going to have the numbers in here once, regardless whether it's a function or not. But what they're going to do is draw two lines. So example, let's say you had a extra point here, 4, 0. Then you would have those two different numbers. But the line would show on here like this. And then you can see that it is two lines here, making it not a function. But we don't have that here. So this is a function. All right, let's take a look at another example. Okay, so again, really quick, all you got to do is look to see on the x values, are there two lines? And you can see there's two lines coming from the one right away. It's not a function. But I also put the points out here so you can see that since you have the 1 going to 4 and the 1 going to 6, you would have 2 points representing that, making it not a function as well. Okay, so now we can determine whether just with mapping if it is a function or not. So let's take a look at a few examples. So take a look at number 3 and determine whether it is a function. Okay, so in number 3 you have an arrow, and an arrow, and each one has its own individual arrow, so yes, it is a function. Alright, let's look at another example. See if you can determine if number 4 is a function. Okay, so since there are no two arrows coming from the input to the output, then yes, it's a function. Alright, now see if number 5 is a function. Alright, so on number 5, this is not a function. Okay, we've got 2 arrows here for 9. So that's going to let you know that it's not a function. Okay, here's another example. See if this is a function. Alright, yes, it is a function. You've got each one of these only has one line. If it had 2, it'd make it not a function. And always look at the x values, the input. Okay. Alright, next I'm going to show you how to do a problem on Delta Math that requires you to drop down and fill in the blank. So give me a moment and I'll show you that. Okay, now let's take a look at this example. So this is the exact same problems we've been working with, but it's asking for a few more bits of information. But it's not a problem, real easy to do. So it says here, fill in the blank, and let's see if I can make this a little bigger. Uh-oh. Alright. So it says fill in the blank in order to justify whether or not mapping represents a function. Alright, so what do we do? Well, first, is it a function or is it not? Well, we could determine, since it doesn't have the 2 lines here, that it is a function. Okay, so the first part of our fill in the blank is the mapping diagram above represents a function. But then we have to tell why. Well, since, and they give you some options here. And if it's a function, you want to put for each number. So for each number n, and we'll get it from set A. And remember what I said about set A, or that first one, is the input. So for each number in set A, there and is only one mapping, which means each line is a mapping. So there's only one mapping for each number. One mapping for each number going to set B, which is the output. Alright, now let's take a look at another problem. Okay, so on this one, we could tell that it's not a function because you have these 2 lines right here showing that it is not a function. So the first part is it does not represent a function, since instead of saying for each, we're going to say there is one number in set A, which is the input, and where there is multiple mappings, and that one number, number 1, has multiple mappings, 1, 2. As soon as that happens, then it's no longer a function. that goes to set B, which is the output. And that's it. So that is today's lesson, and I am Mr. Ware. Thank you, and see you next time.